Hey everybody, welcome. It is 10 o'clock, so we're going to get started here. My name is Lars Peterson. I'm going to be going over using a master modeling technique in SOLIDWORKS this morning. So what master modeling is it's a way of design where you have a single part that drives multiple components. Lots of different reasons to do this, as far as making sure things that fit together, or taking something like what we're seeing on the screen right now, which is, a more free-form design, and breaking it up into pieces where it would be tough for me to model one half of this and then another half of this as separate pieces and make sure that they fit together completely smooth, where it's better if I just do it as a single model and then break it in half once I'm done. So with something like this plastic part, I've designed it as a single body. Here I've got one solid body. I've also got some surface bodies, a couple of them just for me to see where it mounts up to the rest of the assembly. I also have some surfaces that I sort of left behind that were construction surfaces that I used in my design here that I've hidden. I've created a tab here with some of my favorite master modeling features. You can create your own tabs on the command manager. I don't know if you know that. If you right click on here, you can create a new tab. And so I've created a new tab with some master modeling features. I'll probably flesh this out a little bit more as I go through here. But one way of me breaking this into pieces is using a command called split. And what the split command allows me to do is I can make multiple bodies out of a part. I can do this using either sketch geometry, planar geometry, or surfaces. So when I click on the split command, over here is my property manager on the left-hand side. I can choose a trim tool. So like I said, I can use a surface to cut this thing up with. I can use a sketch. If you're using a sketch, it's sort of like when you cut with a open contour where it shoots perpendicular to the sketch plane to cut things in half. I'm going to use the mid plane here to split it. Once I've picked a cutting tool, and you can use multiple cutting tools if you want to use a combination of planes or sketches and surfaces, you can mix and match all you want. When I press this cut bodies button, you'll see that it cuts everything. The surface bodies on the bottom, the solid bodies on the top. It'll break it all into pieces. I have the option of which ones I actually want to break. If I don't check these on or touch any of these buttons, it'll leave it as a whole body. It won't cut it up. So it shows me what it's going to cut, and then I can choose from here what I'd like to actually get split. This is way too much stuff for me. I don't actually want to break all these surfaces up. So if you look at the target bodies here, usually it's set to all bodies. There is a radio button here, so where I can select bodies, and I can pick and choose what exactly I want to cut. So I just want to cut the solid feature, the solid body in half. So by minimizing the amount of stuff that's going to be targeted for cut, when I hit it, instead of it showing me 6 different bodies that it's going to create, it's only going to create 2 solid bodies for me. When you check this on, that means that it's actually going to break that away from the original. If I just check these on, that's all it's going to do. It's going to turn a single body into a multi-body part, but it's not going to create any external files. However, if I double click on this cell, and you'll see that it does highlight which half we're talking about. If I double click here, that's when I tell it, I don't want you to just cut this into 2 separate bodies. I actually want you to create a part out of this. And so it's giving me the option of naming this as a part. So I'll give it one of my fake Google part numbers and save it out. You can also do it from the graphic screen. You'll see that you've got these pullouts. When you hover over one of these callouts, it highlights what body it's dealing with. It's pretty easy here because I only have 2, but if you got a bunch of them, it's nice when you hover over it, you can see, oh, that's the one that it's talking about. If I double click on that callout, same thing happens. It sends me to the save as and asks me to save it as part. So now you can see it's going to save these as external SLD PRT files. So when I hit the green check mark, it'll take a second, and most likely the thing will disappear on me. Let's see. It didn't. I was worried it was, because sometimes I forget to check one of the options. And the option in question is this consume bodies. If that's turned on, it breaks the bodies, but it also gets rid of them. They're no longer in the model. So it just sort of shoots them out and they disappear from your design. I'm not really sure why you would ever want to do that, but that's what that option does. Okay, let me go up to the top here in Window, Cascade. Let's take a look at what's happened. I have two pieces here. If I look at the feature manager tree of those pieces, what I'm left with is just one feature. It's called the stock feature. And so what that is that's the imported geometry from that original part. You'll see that it's got an external reference on it, and that's how this works. Earlier in my assembly design seminar, I talked about external references and that you should probably lock them or break them so that you don't get into the problem of having a released item trying to change itself without you knowing about it because you're changing some other part that's referencing it. When you're doing the master model, you really have to do external references. That's how this whole thing works, is it's pointing back to the original. So any changes I make to the original will be go to the derived parts. So I've got the master model, and now I've got two derived parts. If I make any changes, I want to make them at the master model level, at least if I'm talking about changes to the overall design. I can make changes to the individual derived part. So if I go into my features here and I choose to shell this thing out, all right. I've talked about this warning before, not an error, just a warning. What it's telling me is that there is radiuses that are tighter than that number that I put in there. So when it offsets, that radius is no longer going to be around. It's going to sort of trim itself up. And there we go. This is what I'm talking about, where you see that this offset gives me different results here than it does here. It's just a single line in here because of the width of my offset. All right, but you see that I can make changes to this part. I can do the same with this one as well. So I'm adding features to that stock feature for whatever you want to do. If you want to shell it out, if you want to put in mounting features, that type of thing, and still remain, this is a one-way street where nothing's happening at the master model level. Okay. So there we go. I've got this part, and of course the original. You do want to remember that the split part is time dependent. You'll see that it's a feature in your feature manager tree. So I can make changes to this part, of course, but I'm only able to make changes, at least for an applied feature, to one body at a time. And this kind of gives me a clue as to the fact that I'm not working on both halves of the thing anymore. I'm only working on one half at a time. Even with working on one half at a time, see this is that left half. If we look at this, there was no change there. Because it is time dependent, the feature has to happen before the split happens if you want to see it in the split part. So if I go back to the original and I take this feature and move it above the split, or move the split below it, whichever it wants to do. When I go into this one, it takes a second because it's got to think about it, but now that feature happened in that part. So you do want to be aware of it. If you use the split part, or as I'll show you a little later, this thing called save bodies, that's a time-dependent feature in the tree. Anything that happens after that does not happen in the derived part. And since I rolled it before, it's going to happen on both sides at this point because it went all the way around since it was a single body when that fillet was applied. It does take a second for it to update, but you'll see that it still retains the features that I put in there even though it's updated. And even the shell has happened where it's shelling out that fillet now. One more trick with this split part that you should be aware of. If you right-click on it, there's a choice to create an assembly. You do that and hit Browse, it'll send you out to save this out as an assembly. So you give it an assembly name, you say OK, and here's what you get. An assembly with both parts. These are the derived parts. See, they've got their little Google part numbers there. And they're fixed in the position that they were. Here's where the origin of the original part was. So when it creates that assembly, all it's doing is it's dropping it in according to the origin of the original part and fixing it in space. This is actually, for this example, not such a great way for me to do this because at this point I would want to start doing bosses and fastening features to make this thing snap together. Where if I do it in one part and then I do it in the second part, they're not going to communicate with each other. I have to keep track of both of them now so that, the bosses meet up with one another. I now have the headache of, okay, I had the master model that was making my life easier, but now I'm going to have to pay attention to both these parts when the changes happen individually anyways. So I just wanted to show you this example, talk a little bit about the split part, time dependency, making assemblies from the split. Any questions on any of that concept so far?
Can you work on individual parts and then go back and you said time dependent and take the speakers and roll back? And then...
No, it's a one-way street. So in the master model, there's no way for me to take this boss and shove it back up into the master model. Any changes I make in the master model will happen in the derived. Anything I do in the derived master model has no idea about it. Okay. Questions back there?
Yeah, I came in a little late. Were these two parts created as the save bodies out?
There's two different features. One is split and one is save bodies. They're very similar.
So first you've been working with the derived parts.
They were created with the split. So the difference between split and save is split breaks it up, where save, you actually model it as separate bodies and then just push the bodies out where you don't have to break them apart. Oh yes, I should repeat the question, sorry.
So you typed in the new names of the parts you wanted under that split feature?
Yes, I did. Yes, sir.
Is there ever an advantage to actually working in the master after the split? It's not going to propagate into your two derived forms. Is there any reason we ever want to do that?
Not that I can think of. Typically what you want to have as the last feature on this is the split. So you always want to put stuff above it. I can't really think of, his question was, is there any reason why you'd want to have stuff happen after the split feature? And no, just by accident is typically when people do it. And you want to be aware of it. That's why one of the first things I brought up with the split is, hey, take a look at where this is in the tree. Some of the last things you want on there is either deleting bodies out and then splitting it up. Because maybe I didn't want all those surfaces when I first brought this thing up. There's a lot of construction surfaces that I didn't need to have in the body. And sometimes it's better to do a little housekeeping before you split it. But it gives people a clue as to if they see a split at the bottom, this is probably a master model. Because you can use split, I'm going to do it in a little while, just to make it a multi-body part. You don't always have to use split to create this assembly or these derived parts. You can use it just to bust up a model as well. Does that answer your question? And I answered everybody else's question? Okay. Okay. Also, one thing you never ever want to do in this situation is, you know, I've got these mounting bosses and you might think, well, why don't you just do some top-down design? You know, if I go in here and edit this component, I can grab those edges and put them into a sketch. That is a terrible idea. What it gives you is it's what's called a circular reference. A model is referencing itself. These are both coming from the same model. And so you can get an error where you go to update and it says circular reference and just flips out and none of the stuff you thought was going to happen happens. So do not mix top down with master model. It's a really bad idea because you're trying to grab information from the model into itself. And SOLIDWORKS gets confused when it goes to rebuild it because it's not sure which side you're talking about. Okay, so let me try this again. I'm going to open up another version of this because there's different ways of doing master modeling technique. A little later, I'm going to show you more of a strategic approach when you're trying to do an entire assembly using master models. Or there's one of these things that's more like a consumer product where I just got to break this thing in two pieces. When you're doing the strategic one, you want to keep it as simple as possible. Don't make every feature, do not model the entire thing. You just want to give the major bodies of your assembly. But when you're dealing with something like this, it is a little bit of a better idea to actually go ahead and model this. So what I've done in this example is I have created a couple of configurations. One for the left side, one for the right side. And you'll see that this is fully fleshed out where I've got those mounting bosses and things like that all built into this already. So I've got a left and a right side. And this is nice because internally inside the part, I can do those convert entities or offsets. And it's not going to get confused because it's happening within the same part. It's not an assembly where it's trying to match the parts up together like it does with an external reference. This is more of like an internal reference, if that makes any sense. So with this type of feature, if I wanted to, create some geometry, go into my plane command. Give myself a sketch plane and then open a sketch on that. I don't know if you knew this, but you can actually grab geometry from suppressed geometry. So I've got a couple of mounting holes that are supposed to have pins that go through the shaft that's coming up this thing. I've already got them on the left side. I want to make sure they're always in sync on the right side as well. So I can just do a convert entities. And you'll see that I was able to steal that information even though the feature is suppressed. SOLIDWORKS is okay with it. Okay. Let me extrude this. It's going to be a drafted feature going in towards the body. I want the draft going outwards, and this thing is a thin feature. There we go. So I can grab geometry from one to the other. Also, take a look at how my feature manager tree is. You notice that I've folderized everything. This is just a great thing to do in a part anyways, so that if someone's working with you, they have an idea of what features go where. It's also a good way to make sure that you group things together. Also, for your own benefit. If you modeled this thing 6 months ago and you open it up, you don't know what extrude 57 really is. But if it's in a folder that says this is a mounting boss, you have an idea all of a sudden. Also, I'm going to group these features. So you just can control select these things or shift select it, add it to a new folder, give that folder a name. The other positive that you can do with folderizing information is you can quickly turn on and off everything. So if I right click this left folder and unsuppress it, it's going to unsuppress every feature in that folder. So instead of me having to pick and choose what I want to unsuppress, if stuff is in a folder, I can quickly turn on and off that entire set of features. All right. Last time when I was creating this thing, I showed you how to use the split part to create derived parts. There's several different ways to create derived parts. Another way is just to open a blank part and use this insert part feature. You can find it under insert part. But again, I've created this little toolbar here for some of my top-down or some of my master model features. The plus about insert part as opposed to using a split or a save body is when you do a split or a save body, you only get solid bodies or surface bodies. That's it for the geometry. When you do insert part, you pick your part. I can bring in solid geometry, surface geometry, as well as sketches, planes, axes, any kind of reference geometry that you've put in there. You can bring that forward into your derived part, which you don't get with a split. With a split, you just get a body that's shaped like it was. Here, I can bring in some more information if I want to leverage those sketches later. I have certain planes I'm going to use for mating, whatever I want to do. You can bring in any of that. Also, be cautious with this locate part. If that is checked on, what it's going to do is when you drop this in, it's going to instantly take you into move copy body and ask you where you want to place the body. If you just want it at the origin of the original, uncheck that and it'll just drop it at your XYZ. Or actually, if you click somewhere on the screen, it'll drop it wherever you click it on the screen. So be cautious with that. It's a much better idea. Just hit the green check mark because then it's going to drop it origin on origin. But you see that when I do that, when I pop this feature open, so my first feature is actually the entire part. I've got solids, surfaces, and whatever reference geometry I want in there. Yes, sir.
So if you were to decide after you just import that you wanted to, you go in and edit, and you and then also at the same time, if you decide you want to clean it up and you do much stuff and want to reduce the amount of reference geometry.
Yes, his question was, can you change your mind? Maybe I didn't want surfaces. Maybe I wanted to bring in sketches. Can I filter this out? If I go back into this original feature and choose to edit the feature, it takes me right back to the property manager because I forgot to bring in the sketches that I wanted. And that actually was true. I did forget to bring in the sketches I wanted. So good thing you asked me because I can show you. Yes, I shouldn't even said anything. I should have been like, let me show you. Yes, now I have sketches. So here are all those sketches that I can now use as reference in this part if I need to reference them again. What's up?
On that note, so if you were to change, can you change those sketches? If you were to change one of them, would it go back to the other part and change it there too, or is this the same as the split body where it's only going to make those changes in your derived part here?
You have to make them at the top level. So anytime you're doing master model, you always want to go to the top level. You see that when I right click on it, I don't get the choice to edit the sketch. Occasionally, sometimes you'll get edit in context as a choice, and that actually will open up the master model for you, giving you a clue. It depends on how you shipped it out. With an insert part, it really doesn't have that connection like a split part does, has a feature that it's going back to. With an insert part, you kind of just drop the whole thing in there. His question was, can you edit the sketch once you've brought these sketches in? And no, they're just for reference. If you need to change the sketch, you need to do that at the master model level and not at the derived part. One other thing is this brought in the whole thing. I didn't want the whole thing. If I right click on this inserted part and go to external references, it shows me all the stuff that I brought in, lots of bodies and sketches, but it also shows me which configuration I brought in. So brought in the default, because that was the one that was active when I chose it. I can switch that. Takes a minute to update because it's got to go back to the master, grab that configuration. There it is. Again, I can start making changes to this. I can start adding features if I need to. Again, it's that one-way street where anything that I do in this derived part, MasterModel has no idea about it. All right, so I'll do that again because I need to have the right half as well. And again, I want to make sure that I have everything that I need checked on here. If I just want it to be dropped in at the original origin, make sure that that is not checked on. Hit the green check mark instead of clicking somewhere on the screen. Go into the external references and dial up that I want this one to be accessing the right side. Wow, that was really fast compared to the other one. Okay, again, I want to give this thing a part number. And buddy too, so that I can actually insert them into the assembly. And I'll start a new assembly. So this one is a little more work than the split part. The split part was nice. I could just right click and say, give me an assembly, and it would find all the pieces that were split out and put them together. Here I have to do it manually. Same thing with that green check mark when you're inserting a part. I don't want to just click any old place here. I want to keep the same origin that I was using before so that they fit together nicely. So it does take a little bit more work, but you get the reward of having all the reference geometry that you want come in if that's something important to your design. And there we go. I'm going to make this part transparent. Just so you can take a look. So remember, I based these two bosses off of the other one where I copied it internally inside of the part. So if I go back into the master model, let's say I create the left side here and I edit this. When I go back into the assembly, because the information from the right side is based on the geometry from the left side, those holes are both going to move. And so that's where you start to get the power of the master model, especially in something like this when you're dealing with a product that's supposed to, dovetail and fit in perfectly together. These things are always going to match up. Where if I had dropped it in as a split part, put those in later, I would have to monitor each part to make sure that they matched up. Doing it this way, I ensure that they're always going to fit together. All right, any questions on that? Yes, sir.
Is it best to keep your features simplified instead of having like snap features or whatnot, and just try to keep it simple? sides? Built or?
Again, it depends on how you're using this. If we're using it at the strategic level where there's a lot of parts that are referencing your master model, it is best to keep it as simple as possible, where you just have the major bodies that you're working on. Then in the derived parts, you go in and you do all the geometry. In fact, when you're doing it at that level, you only want to put in features where the parts mate together. If there's a feature that has nothing to do, it's on a single part, don't even design it. But when we're talking about this, where it's a 2 or 3 piece type of thing, where it's organic shape and you want to make sure that shape is coming off, it's better to design like I've done here, where I've actually gone in, I put in the ribs, I put in the mounting bosses, I put in everything where the two locate to each other, just so that,
For consumer products.
right, for smaller levels. Once you get, 3 or 4 pieces in there, you may want to start toning it down and leaving stuff for later on. Also, when it's 2 pieces, again, if it's something that it affects both parts, you want to model it in there, because these snapping features and mounting bosses and stuff like that go into the mounting boss on the other side. You definitely want to model that up. So does that answer your question?
Yep.
Excellent. I hope I repeated it. He was asking, do you want to put that much detail into a master model? And it's really when the parts have to fit together, you need to put those features in there. You had a question, sir?
Yeah, I have a few notes, just quick questions. I was really surprised that you could reference geometry and suppress the sketch. And I presume you can't do the same for suppressed features?
Well, you're not going to be able to reference like faces or things like that because the faces just aren't there.
Right, but I would have said the same thing about the sketch. It's just surprising. Are there other examples that you know of or things that?
I can't think of anything, as far as like physical geometry where you're talking about faces and edges and things like that. When it's suppressed, there is no face or edge for you to select. But when you're dealing with reference geometry like a sketch or a plane or an axis or something like that, you can pick that even though it's suppressed and just convert it, because it is actually something that's got a XY coordinate regardless of whether it's turned on or off. Is that I'm sorry, I'm never repeating these questions. His question was, can you reference suppressed geometry that's not sketch, if it's a solid or a surface or something like that?
You could reference suppressed plane. Perhaps. I mean, you can try it later. Not really.
Yeah, I don't know the answer to that one.
Nested folders, are those supported yet? You should folders.
Yeah, you can nest folders.
This is the solver, you could nest folders.
I'm pretty sure you can, but this is one that I can do on the fly. I can also try that plane, suppressed plane thing. So if I right click here, yeah. So his question was, can you do nested folders? And right there, I just did.
2017.
This is 16.
16, great. And then I have one more question, I'm sorry.
Not a problem.
I noticed you have a dual feature tree on some of these models.
Mhm.
I've always wondered, or since I was at least wondering what's the purpose there? Is it just to reference like features at the top of the tree and the bottom of the tree at the same time?
Sure.
Mainly? Or is there a fundamental difference between the upper tree and the lower tree?
No, there's no fundamental difference. They're exactly alike. His question was, sometimes I have split feature manager trees. How you do it is if you go up to the top, it's really hard in earlier versions because it's just like an invisible line and you have to wait for your cursor to show this parallel lines with an arrow going up or down. In 16, they gave us this big giant bar here that we can pull. The reason that I use this sometimes is I can do things like I can switch configurations and see what happens to the tree without having to flip back and forth. Or I can have feature manager tree down here and a property manager. If I have to pick a bunch of features, like to do a mirror or a pattern or something like that, I can have my property manager up here, my feature manager down here, and start picking stuff from there. So that's why I do it. Then they all, if you set it to, if I'm looking just at the feature manager tree itself, there's no real point in that because they're going to be identical. There's not one is driving the other or anything like that. It's just viewing it. But sometimes I want to see the tree while, maybe if I'm applying appearances and I can see the tree, it's just nice. Typically I do it when I'm working with multiple configurations, so I can switch configuration and see what's getting suppressed and unsuppressed in real time. Hopefully I did end up on the right one. So his earlier question was, it's cool that I can reference suppressed sketch geometry. Can I reference a plane that is suppressed? And right here, I am sketching on a suppressed plane. So the answer is yes. Again, with body geometry, like a solid body or surface body, obviously I'm not going to be able to pick faces or edges, but when it comes to axes, planes, sketches, things that are just a physical thing that's in space, I can pick that, because suppressing it just turns it off, but it doesn't get rid of it. Okay, any other questions before I leave this little joystick behind? Okay,
I got one.
sure.
When you do the split body save out, it reference the material as well here, but when we do import part, it doesn't.
That's correct, because when you're doing this type of the insert part, you're bringing across the sketch geometry, but it's got its own material driven at that part level.
But the split and save bodies features will bring material over, is that right?
They look like they do.
His question is, when you do a split, does it bring across the material property? And I'm not sure, this thing's made out of plain carbon steel. We can do it really quickly here. Oh, whoops. Yeah, it brought across the material. So it does do it from the split, but when you do insert, you have to apply the material at that inserted part. I didn't even notice that, but it was easy enough to prove out. Okay, let's kill all this, open up another component, bless you, that I had from the plastic part design. So that last part I did in last month's plastic part design. I did this one in last month's plastic part design as well. And I modeled the top and the bottom half of the box, which is a good idea, because if I am to change this box, the top and bottom always fit together, which is really what I'm after with this design. You can use the split command not only to create new parts, but just to create new bodies. So right now, this thing is a single body, which is not so good. You're not going to be able to get the top off the bottom. Remember, if I double click in this cell or double click on these callouts, it automatically trips the trigger where it says, okay, I'm going to make a derived part out of this. But if I just check this on and say, okay, creates a split feature, but it does not create any derived parts. All it did was take a single body part and make it into a multi-body part. So I want another piece. I actually want like a shelf here that they're going to put PCB boards and other cool stuff inside the box. So I'm going to move this up a little. Hey, any similarities between real models is purely coincidental. But yeah, this could probably be used in avionics maybe. All right. So let me make a sketch here, and I'll do a convert, which when you pick a face and you hit convert, it automatically picks the exterior of that entire face. It's really nice because if the face changes, the entire exterior of that face will update with that convert. it's a one-shot thing. When you pick the face, you hit convert, it converts it, and you're done. If you pick convert first, you can pick more than one thing. So if I want to get all of these holes, I can do that. And then if the holes ever move around, this will update to make sure that this part actually gets bolted in there correctly. But you'll see that I'm able to pick multiple items. If you pick the convert first, if I were to pick an edge and then hit convert, it would just grab that edge and I'd be out of the tool. But if you pick the tool first, then you can pick multiple edges. All right, so I can extrude this. You want to make sure I turn off this merge result or else I'm going to have to split the thing all over again. So by turning off the merge results, I'm going to end up with a 3-body part here where I've got the top, the bottom, and the shelf as well. And I can make more changes to it, whatever I need to do to flesh out this design. Okay, so I've got a multi-body part that I started off by using the split, and now I'm just modeling more bodies, making sure I don't merge them. So I want all 3 of these to end up in an assembly. Before I do, you can also put in, when you're doing master modeling like this, you can put in OTS parts if you want to make sure that they fit into your design. This one's a little contrived. Typically, if I'd had more time, I would have grabbed a PCB board or something like that. But I just went out to McMaster Car and grab some hardware because I want to make sure that an 8mm bolt fits in there and I've got enough threads for a nut to go on the bottom as well. So I can check that out at this level. I showed you the insert part earlier when you're using it for master model, where you're actually inserting the entire master model in whatever reference geometry. You can also do it sort of as a multi-body assembly, where if I wanted to bring in, let's say, a part from McMaster, I can do that. But this time, I'm going to turn on this locate part just to show you what that's all about. Now, if you hit the green check mark, it always puts it in at the origin. There it is at the origin. But notice because I turn that check mark on, it automatically takes me to this move copy bodies feature. It's actually just a move body. I don't have the choice to copy it. I can move this delta X, delta Y, delta Z, or I can rotate it. Unfortunately, you cannot rotate it and move it at the same time. If you want to rotate it 90 degrees and then move it over, you have to do that as 2 features. Or if you press this button that says constraint, you can actually mate it in place just like you're mating it in an assembly. So if I pick a cylindrical face and another cylindrical face, it defaults to concentric. There it is down there. When I say add, it starts building a list of all the mates that you've put in there. If you get out of this and you, oops, I forgot I want to do it, you can just edit the move copy feature and put in more mates as you go. But you can put in as many as you want here. So 2 planar faces, it'll put in a coincident, and there we go. And what I mean by editing it, if I go into this insert part and I hit the expand in front of it, you'll see down here at the bottom, I guess I'll put my mouse over it, down here at the bottom, not only does it bring in solid body, surface body, sketches, whatever reference geometry you want, but there's also this move copy feature. So if I needed to put in more mates and forgot to, I can just edit that feature and it'll bring me right back to it. I can get rid of these mates or put in more if I need to. Let's see if the nut fits in there. Also, when I hit the green check mark, remember it puts it origin on origin. If I just click somewhere out in space, that's where I get it, somewhere out in space. I'm not really sure where that is until I start rotating it and see how it actually decided to put it in there. Oops, not that one. A circular edge and a cylindrical face will default to concentric. And I can check this thing out. Does it have enough threads? Do I need a longer bolt? Does the thing actually fit in the hole? Again, you can put OTS parts into this master model just to make sure that your design actually fits in the hardware or whatever you want to put in there. What you want to make sure you don't do is don't derive these out. There's no point in that. If you have an OTS part, blow those out before you ship the thing out using split or save or whatever you're going to use, and then put the real parts in at the assembly level. Here you're just doing sort of a reality check at the model level to make sure that your off-the-shelf parts go there. But there's no point in having an off-the-shelf part inserted in there and then derive it out. Why don't you just use the original? Okay. So I've made sure it fits. I've got the design. Everybody's happy. Yeah, that's the thing we're going to use. I want to ship this out as its own bodies, but I do not want to derive the OTS parts. So you can just delete these. Again, this is pretty contrived because why am I deleting something that I just put in there? Maybe if you put it in a while ago, inside the feature manager tree, you want to make sure that you just have the bodies that you want in here. So it's always a good prep to take a look at your bodies before you choose to save bodies, which is the next tool I'm going to use, just so you just have the bodies that you want. Another thing that is a really good idea is naming these. Because if you don't name the body, like let's say I got this one, it's called split at this point because that's the last feature that was put in there. If I put another feature in, like a very small fillet, that body has changed position in the feature manager tree. It's also changed its name. And this is where people will get into a lot of trouble when they're inside of a master model because they'll have this master model, they'll ship out the bodies, and then they'll go in, they'll start making changes. Even if they're, smart and they make sure that their changes happen after the split, you're renaming that body that's getting split out or getting saved out. That's where sometimes you can run into issues where when you open up the assembly, all of a sudden the base or the stock feature isn't there. What happened? Well, it was looking for a particular body name and that body name is no longer there. Usually SOLIDWORKS is good enough to figure it out, but it's not 100%. So it's always a better idea instead of just relying on that to actually give a name to a solid body. You can either do a slow double click or if you select on it and press the F2 button, that's a Windows trick for rename. And I can give these things, a little bit better name than whatever the last feature that was applied to it. You cannot use the same name twice. That's what happens when I talk and type at the same time. All right. But now you see if I give them an express name, even if I add a feature like to the top here, still called the top. Doesn't matter what features I put on there. It's not going to rename that body. The only time that body is going to change its name is if you do something like delete a face and turn it into surfaces or something like that, where you actually take away the body. But if you give an express name to a solid body or a surface body, you start adding features to it, it will retain that name. And that will make your life a whole lot easier with you not losing a reference unexpectedly. And I'll cover a little bit more what you can do if you do start losing references or it's not sure which body it's supposed to be using or it comes up with the wrong body is another thing that can happen. There's ways to actually force it in later. Okay. There is another command that I want to show you. Insert features. It's very similar to split, but it's called save bodies. It's under your insert features, or I always just, if I can't find something, just type it in there. And there you go. It's even got the same icon. It is a time-dependent feature, so it will show up in the feature manager tree. You do want it at the bottom of the feature manager tree. But it's for when you've designed like this. I don't need this thing cut up. I've already got the bodies that I need. I just want to push these bodies out to it. So the split is if you're actually breaking the part up. Save bodies, you've already got it in multi-body form when you designed it. But they do the same thing. I want to assign these names. Typically, I was showing you that a GPN is a good thing to use as a name. If you've given a body a name, there's two places you can hit. You can either hit this save icon up here, or if I go back into it, that's the wrong one. This auto assign names does the same thing. It just grabs the name off of the body that you're doing. But again, it's better to give it actually a GPN for what we're doing here, because we don't want something just named top or bottom, because there could be tops and bottoms to all kinds of things. You don't want to have bad references inside SOLIDWORKS. There's another thing with the ability to create the assembly on the fly. The split and the save body both have the ability to right click and say create assembly after you've done them. But if you know you want to have an assembly right away, there's this create assembly box in both of them, where if you browse and give it a name, when I create that, not only is it going to create the three components that I wanted it to make, it's also going to make the assembly for me. So if I go into my Windows and I cascade, it opened up the assembly for me automatically with the name I just gave it. And it's got the three components fixed in space that have external references back to that original stock box. As I was saying before, it is very similar to the split command, where you always want to have it on the bottom. So if I were to cut some holes in here for our harness connectors, make those all equal to each other and give them a size. When you are cutting at the multi-body level, you have the choice of whether you're just going to cut into one body, or you can pick and choose. If you turn off this auto select, you can actually pick from here which bodies you want to go in. Or there's a choice also for all bodies, where then it's going to cut any body that's in front of it. But if I go into the assembly, no holes. Why not? Regen's not going to do it. It's the time dependence thing. So remember, the hole that I put in has to happen before that save bodies. When I roll it before the save bodies, there they showed up. So you have to remember that time dependent thing it gets a lot of people where they'll thought that they put a hole in. I swear I did that. It's because you got to make sure that it happens before those bodies are pushed out into their derived parts. And as I was saying before, typically what I like to see at the bottom, you should folderize this definitely. But leave these two out of the folder and just have them at the bottom so that you're sure that, yes, I got rid of all the unwanted bodies that I don't want to ship out. And yes, the thing that I shipped out the derived parts is the last thing to happen in my feature manager tree. That's just a little housekeeping to help you out when using this master model technique. And as I was showing you earlier, if you do make a change to the master model, of course, all of them change inside that model, but they also all update in the assembly. And that's really the power of the master model, is that I can just have one spot where I want to make the change and drive all the changes in the assembly from that one feature instead of having to change part by part by part like you would if you're doing this one part at a time. Any questions on this example before I move on? Yes.
Naming bodies. So it seems from the presentation, it's not.
No, it's not.
Go back before when you had done it, it won't rename the body. But just wondering.
Actually, it does. It's weird.
Yeah.
So his question was, is naming a body time dependent? Yes and no. It depends when you named the body. So I believe if I roll this thing up to before I split this thing, when there was only one single body,
There's still a name. It's just hidden.
right. So I've still got this thing called vent, right? If I roll this back to when I just had two bodies, now they come back to it. So if you do anything that creates a new body or changes the amount of bodies that you have, or things like doing knit surfaces and forming a body, they're going to have different names depending on what features were applied to them. It shouldn't really be very time dependent, except for that. If you've added bodies, if you've subtracted bodies, something like that where the count changes, that is time dependent. But if I go to after that, you'll see that right when I split this, even though I didn't name these until way after I did the split, it remembers, oh, this is that part that he called top. So it will try its best to remember those names. I hope, does that answer your question? Sort of, like I said, it's weird, but that's the thing. If there's a different count of bodies, it'll remember what the names were when you had 4 bodies. It'll remember what the names were when you had 3 bodies, 2 bodies. But anytime you give it an express name, it'll try and hold on to that name. Once that body comes back into existence, it'll be like, oh, he had named this top. It even remembers, because you can do transparencies and things like that on a body. That one was not a good one to, and it'll actually remember. So when you roll back, if you hadn't made that transparent before that feature happened, it'll go back to solid. So it remembers that as well. So you'll see that sometimes when you're doing rollbacks, all of a sudden stuff will disappear or things like that. That's because it was hidden back when you were doing that feature. Also, if you do something like you do a delete face, turn it into a surface, and then you change the surface and put it back together, you cannot name it that same name again, because some point in the history of the part, it had the name top, and it's not going to let you have 2 bodies named top, even though they happen at different times. It's going to give you a no-go on that. So you want to be aware of that.
Hey, Mark, we have a question online.
Sure.
So, Peter was saying that in the past, he's found safe bodies to be fairly unstable, especially when adding. His solution back then was to use
Well, the thing is, I'm going to go in through an example. So the question was that we've had somebody who's used save bodies in the past, and they've had issues with it where bodies will change names and it'll lose the associativity because it's looking for a particular name, can't find that name. So it gives you nothing. And all you've got is these error features, and the whole base part of it's all gone. You can, and I'll show this in an example a little later on, you can actually force that. You can go back in, you can either push the change from the master model or from the derived part. It's better at the master model to do the push, but I'll show you that I'm aware of that, and that's why a lot of people get sort of wary of, oh, I tried master models, and every time I made a change, everything exploded, so I hate it. If you understand where the issue is coming from and how to deal with it, it's not that unstable. Insert part, but to answer his question, he said, is insert part better? Insert part is better because it's referencing actually the part file. So it's a lot less likely to lose the entire link to where the part is as it is to, because when you're doing a split or a save body, it's looking for that part and a body that's in that part. And that's where the problem happens, is that body change names, or you have more bodies than you used to. And it gets confused as to, was this body 5 or body 6? Which one did you want for that? So insert part, to answer the question, yes, is more stable. But the split and the save bodies, if you know how to either push or pull back those references, which I'm going to cover in a little bit here, you'll find that they are a little bit more stable. Again, I'm trying to show all the different ways, because there's a lot of ways of doing this master modeling technique as to which one's best and which one should you use. The insert part, I think, is probably the most robust and the most, because you get the ability to have all that reference geometry and everything. That's a plus right there. But also the fact that it's less likely for you to go have to do any sort of, emergency repair afterwards as well.
You have to create a configuration for every type of, for every body.
Right. If you're going to do a multi-body, though, you can bring in the whole body and actually just chop it up. You can bring it in and cut the whole right half off, or bring it in again and then cut the whole left half off. So you don't always have to do it at the master model level. You can bring it in and then take that inserted body and say, okay, I just want to see the lid. I just want to see the feet or whatever, and cut everything else that's there. It'll only reference that geometry that's left. So you don't necessarily have to do configurations. I like doing it that way just because I know what's happening at the master model level, where when you do things at the insert part level, there's no paper trail on that. When you're doing split bodies or save bodies, you have a feature that you can see, hey, this probably is something that has, I'm using a master model, where if you do insert part, there's no clue on the master model that an insert part has happened somewhere else. Okay, so these two examples were definitely what master modeling typically is used for, something where it's an organic shape and you want to split the organic shape into multiple pieces and still have it fit together perfectly. Or in this case, I've got several pieces and I want to make sure they always fit together. And rather than doing top-down design, if you do master model, the problem with top-down design is that you can end up having a bunch of parts referencing different parts, where this one references a hole over here and a hole over there and a part from there. And so you can get like 5 or 6 external references coming from different locations, driving the geometry of your part. When you're doing master model, there's only one location that's coming from. And so it simplifies the whole thing as far as keeping track of it, which is part of the headache that people will get into when they try and do top down, is where's this reference even coming from? How many references are happening here? In fact, I'll show you a little bit more of that idea that I had as far as a strategic type of design. So I was working on the Pelican, the little kayak that flew. Thing was getting way too heavy. Had a combustion engine, was almost 2,000 pounds, only held one person in it. Now I've got a little jet ski idea. It's actually a hovercraft. You hold two people on it, much lighter, gets the job done. This one obviously you wouldn't want to use in colder climates, but it looks like it might be fun in Jamaica or Cabo or something like that. So one problem that people will do is trying to do too much in the master model. You want to keep this as simple as possible, where you don't want to build the entire model and then you'll see that I've got this thing as a hole and a top side. There's the wing, the tail, where I've got master models for each subassembly. It's a bad idea to build the entire assembly as one part and then break those into derived parts that are subassemblies and then break that into a derived part that's the pieces in the subassembly. It just gets too complicated. You have a derived part of a derived part of a derived part, and now it's getting complicated. Again, we're trying to keep with the master model this whole simplification thing. You can also see that I didn't put a lot of geometry in this thing, where I only have geometry like here where one part bolts into the other. I want to have that type of geometry. You also want to steer clear of just simple boxes and things like that. Prismatic stuff, really, you don't really need to do that. The only thing you should be modeling is the complex surfaces that you want on this thing, as well as where the parts fit together. And that's it. Just give it the major bodies, how do they bolt together, and then from then on, use this master modeling technique to flesh it out a little more. Let me show you what I mean. I just want to see assemblies. Here we go. So you saw that I had a really simplified thing where it just showed the ring of where the fan went and how the fan bolted into it. But here at this level, I've got these pieces that I started with the master model. You know, if I roll back to here, it started off just simplified, and then I put in all the detail at this level. You want to have a simple master model when you're dealing with like a strategic idea like this. Also, there was another thing that I had inside of this assembly that I had a driving sketch. So here is the big idea. I just gave it the very basics, you know, what does the wing shape look like? How does this thing look like from the side and from the top? And then designed around that. And every master model that I was using, I started out by opening up this part, saving it out as the master model name, and then building it around it. So they all were using the same sketch. So it's a good idea, rather than, again, trying to have a master model that's everything, breaking that down into sub-assembly master models and then breaking those into smaller models, to actually start off with, here's an overview sketch, and then building a couple of master models that fit into that. Another thing is sort of the command and control of this. And there is an option inside SolidWorks that if you are going to be using master modeling technique and you're going to be working in collaboration with other users, you want to make sure everybody's on the same page and know who's in control of the master model. Unfortunately, one of the default settings in SolidWorks under external references is to load the reference documents. And I get people asking me this question a lot of time. How come when I open up a part, all these other parts open up? When I close out my thing, I'm looking at all these parts that are open in their own windows. I've got that happening right here. This opened automatically because I opened up the assembly that, or the master model that was referencing this. Same with these bolts and nuts, because I had opened up that box that referenced those came across. This can lead to problems because whoever opens up something that's made with a master model, the master model actually loads up into their RAM. And now they've checked it out. So if the guy who's supposed to be in control wants to make any changes, he can't because somebody else has opened up one of the derived parts. So if you are using this command, it is a great idea to say either prompt or none, because you can always, go find the file if you need to open it up. But if there hasn't been a change to the master model, this isn't going to hurt you. What you want to do if you are dealing with a collaborative environment and you have a master model, you want to have one person who's in charge of that. If they're like, hey, you know what, the bench is too short, we need to lengthen that. You should have one person who's controlling that driving part and talking to anybody who's working on it. Oh, the guy who's doing the bench, he's got to do the seat and the top side of this thing. He should load up his model so that all his reference models update. Another one, don't turn this on. This command, I talked about making stuff too complex, where when you're doing top-down design, you can have a part referencing many other parts inside an assembly. If you turn that on, a part can reference many parts in one assembly and reference many parts in another assembly, which is a terrible idea. Not really sure why they gave you that, but you can easily blow stuff up by doing that, because you can do an external reference in one assembly and another. And if the people who are working on the assembly don't know this is happening, you can have some crazy stuff going on. So don't ever turn that one on. And it's a good idea to set this to not loading up your reference geometry. It'll take care of that. Why is this stupid window always opening up in RAM when I open up the part? It'll also cut down on your load time at all, because a lot of times when you bring in the master model, depending on how much complexity they put into it, you might just be working on the simple lid, but it's bringing over some, 80 meg part that you just want to see this much of. So it's taken forever to load this thing up. Why? Because you're loading up the entire master model just to look at one of the derived parts. Now, when I open up that same assembly, now when I go to cascade this, no other parts are open. Whoops. There was another part open. Let me try that again. None. Okay. Try that again. Now, no other parts are open. So when it's set to all, which is the default, you always get the reference geometry coming in. What you lose by that, so I told you what you gain. You don't have the part opening up in RAM. You don't have to wait for the thing to load. What you lose is these no longer have a link back to the original. You see the question mark? This little symbol right here, it looks like a minus sign and a greater than sign. That is your visual cue to let you know that there is an external reference here. If there's a question mark after that, it means I did not load the original, so this is what it looks like last saved. Again, if no changes have happened to the master model, you're not going to have any sort of problems with that. If someone changes the master model, again, you should just have one person in charge of the master model. He should say, hey, I know you were working on this top side. I changed the master model. You probably want to take a look at that. So if I open this in RAM, any changes that have happened instantly will update, where when I rebuild this thing, question mark goes away. It checks back to the master model and loads any changes. But that's how you should roll. You should have it not load up the master model, so that they don't check it out of EPDM and, you know, have the talking stick where they're making read-write access to the thing. You should have them not open it up and only open it up on demand. When you say, hey, there's been a major change, send out an email. Anybody who's working on this, I changed the master model. People that are working on the derived parts can load that up into RAM, hit refresh, save, and then they've captured that change inside of their part. But definitely you want to keep it simple, and you want to have communication where there's one person in charge of the design, and everybody who's working on the design will get updated as far as changes that happen. Okay. Did I beat that one to death? You guys got that? All right. Because that's an important one if you are working on something like this. Okay, let me get into a little bit on Peter's question earlier where he was talking about, well, if I change the amount of bodies and things like that, I've had issues. And that definitely is a real problem. You just need to know how to address the problem when it comes up to not have that be something that destroys your whole day. So let's take a look at, I've got this, it's the skirt. It's got these little frames here. Some of them have holes in it to allow the air to go through. I'm going to make some changes to these two. Make sure I've got names on these. So again, you do want to have an express name that you've given to this thing. All right. Apologize. Watching me type is probably not that exciting, but it is something that's very important. You do want to make sure that each body has a given name. If you're not going to be using that insert part, it's still even a good idea to do when you're doing insert part. If you're working on multi-bodies, give it a name, just so that the name doesn't keep changing on you. Because you'll run into problems, not only when you're doing master models, you may run into problems inside that part because it was searching for a particular body name and it can't find it. Anyways, let me save this out. And I'll do that save bodies. I wish save bodies had when you do a search, I guess if you look over at this one, it doesn't have a clock over it. You'll see some of these things have a little icon in front of them. If they have an icon, there's a button associated with it that you can customize and put on your command manager. No icon means no button. So save bodies, you always have to either do the pull down or do the search to get into it. Okay, so I'll do that auto assign name trick. I'll make it into an assembly. And create an assembly with derived parts in it. You can either open these up in their own window, or you can do edit component. Again, you just want to make sure that you don't do any sort of external reference. And things that are going to get you external references are offsets, convert entities, extruding up to a surface or up to a face. Those types of things will give you an external reference. But if it's just referencing itself, there shouldn't be any problem where, like, if I do an offset, those features don't have any external reference on it because it's only referencing its own geometry. It's only referencing the edges of its own part. So, okay, a simple enough change. I wanted those frames to be hollow so that the air can get through and fill up the skirt and get this thing hovering like I was hoping it to. And I used the save bodies. The issue that someone had asked me about earlier is that they didn't like save bodies because if they did something where it broke up the bodies that they were using, they could have errors somewhere down the line. So here, I'm going to break these into their own pieces. Oops, I did not check anything on here, so let me save this. I'm not saving them out as external parts, I'm just breaking them up. And I'm going to move that in front of these save bodies. So what has happened here is this save bodies, when I pushed it out, it had, 7 parts? Now there's 9 parts, or 9 bodies to act on. So this is where the confusion can come in for SolidWorks. When I go back into that assembly, I don't have the other half now. And if you don't name the bodies correctly and things like that, or you've got some feature that it can get confused as to which body it is. It was kind of a crapshoot as to whether I was going to get the left or the right here. Which one was it going to rename the name? So that's the crux of the problem that the guy was asking about, is that, hey, if I break this thing into bodies, now all of a sudden, well, it gave me the wrong one. I wanted this side or what have you. So there's different ways of fixing that. One way is if I go into the save bodies, this is what they call the push method, where I'm pushing it from the master model down into the derived parts. If I go in to edit this, and I notice that this one is frame 5 right now, I wanted this one to be frame 5. If I double click on that, I can push that body into frame 5. You see it cleared that other one out. So it's kind of weird because it's not, if you right click and ask for properties, it's not something you can see. You have to go into the command and then you have to double click on the line where that body is coming from. That gives you the ability to push that body into any of the parts that were created from this. So if it's grabbed the wrong body, and when it does that, all the features that you put on there, they're just going to explode because they're acting on faces that are no longer there. Where here I can say, oh no, I wanted this body to be this part. When you do that, I say, okay, it takes a second because it's updating all of those derived parts for me. When I go back into the assembly, now it's using that part for the body instead of the one that was in the back. It still may have some problems as far as this one, I actually used the wrong body. So the face was completely different. With that, you would need to edit it and make the change manually. If I did this correctly, there we go. That's the one I want. Let's take a look at the assembly now. It fixed itself because it had that face that it was doing. If you move it from, it's a completely different body where all the faces and edges are not matching up to the original, you're going to get problems with that feature. Where, like I did when I picked the right-hand side of number 4 to be frame 5. But when I said, no, I want the left-hand side of frame 5 to be what's frame 5 now, it had that same face and it was able to update correctly. So there are still some pitfalls as far as using this. You have to make sure that it at least has the basis of it's referencing the same features or the same body that the original was. If you completely switch it and pull the rug out from underneath it, of course the features are going to explode. But if you say, okay, well, I just want this half to be the one that I'm using now instead of the whole piece, it has the same faces. It has some of the same edges. It can usually figure it out for you. You can also do it from the component level as well. Where I can edit this feature, and you'll see it brings up the whole model. So if I wanted to switch out which body it was using here, I can pick from a list of bodies that it has. You see it's showing me only the original one, so it isn't as robust at the top level. It's better to do it the master model because you can use bodies that have been newly created. When you're doing the pull method, where you're doing it from the child, the derived part, you only get to pick the ones that were there when it first created the body. But sometimes you can get an error where it just didn't update well, and you can force it. You can say, no, I definitely want you to use this one. And it'll reload it and often take care of some issues that you have. So 2 different ways of doing it. You can either push it from the top level or pull it into the child, as long as it's a body that was created when you created that save body feature. Hopefully that answers his question. That's the root cause of it. Again, insert part, you're not going to have that type of issue happening as you will with saved bodies. So you do have that sort of you're on thin ice, but it is nice because it breaks it up and puts it into an assembly for you automatically, where you don't have to go in and do all that stuff manually. So there's pluses and minuses on both sides, but that is what was happening to him earlier, and that is the way to solve that issue. Okay, any other questions? Yes, sir.
If you go back to the master model, you had mentioned that you couldn't rename any of the bodies that previously named, right? So 4 bodies which have a split, actually before the body command.
Oops, I'm looking for, I'll get it one of these times. There's the master model. Okay.
Yeah, so you mentioned that you can't rename any of those 4 split bodies as frame 5 or frame _5, for example, because it had been previously named.
Right, and you'll see that, now it got rid of those names for me.
Did you try that?
I sure can.
Seems to be that now there's no way to go back and.
No.
Okay, so now is there a way to go back and, let's say now, okay, I want frame 5, 6, 4, 5, 6, and 7. Is there a way to go back, undo the fact that you had renamed to 5, so that you can actually have the proper naming right before you do save body out?
That's a really good question. So his question, let's see if I can rephrase this correctly. So you saw that when I tried to name this thing frame _4, it said, hey, you've already used that name, no dice. The question that he asked is there any way to go back in time, take that name out of there so that you can use it again? And truly, I don't know the answer to that, but I will find out for you right now. So maybe I do want something called frame 5. I'm just curious if I roll back this. Okay. Go to split. Can I use that name now that I've, given it a lobotomy? Yes.
You had to sort of create a new dummy.
I had to create a new dummy name because at some point there was something called frame 4, and it looks in the history of the part and is like, no, at one point you used that name already. You have to go out and clear it out and say, no, we're never using that name. And then later go and use the name again.
And you potentially have to go like in between every layer to find features to see where that existed from the find.
Yes. Well, if I didn't have anything to do with this and came to it and was like, I really wish that, yes, I would have to kind of do some investigation as far as the rollback and see when that name first appeared. Luckily, because I'm the guy doing it, I remembered, oh, it was before the split was when I put those names in. So let me clear out those names. But definitely, if you do want to get the names back, this is probably going to make those drive parts go bonkers because the 4 and 5 have kind of switched. In fact, let me rename this one 6. Yeah. 4, 5. All right. Cross your fingers. It was okay with it. That was unexpected. Okay, as long as it has the same name, it found the one that I called 5 and the one that I called 4. So because it was still referencing that same body name, I was okay. If I had blown the name out completely, it probably would have failed because it wouldn't know, where's the frame 4 that I'm looking for. If I'd left the name as old 1 and old 2, when I go back in here, it can't find the body that it originally had. I would need to go and do that push or pull to remind it to say, hey, use old 1 now, use old 2 now, because these are the new names we're using. But that's the root of the problem that Peter was talking about, is that by giving it different names or creating more bodies than you had before, sometimes the split or the save bodies will give you issues because it's not only looking for a part location, it's also looking for a body name inside of that part.
Another question too, it's a quick one. When I do edit part in an assembly, everything goes to wire. How did you get that? So that it didn't
So it didn't do it for me? Good question. Okay, so his question was, is kind of unrelated to what we're doing, is when you hit edit component, see how mine all stays nice and shaded like he would like it to? It's right here. I have it set to opaque. You have the default one, which is transparency. Everything goes transparent except for the part that you work on. And the idea is that I can actually pick through the transparency to get just the part I'm working on. That's why their reasoning on why you would want that. I don't want that, just like you don't want that. So it's right here,
How would I find it if I didn't
opaque.
do that myself?
No, this isn't in a new tab. This is in your assembly tab. It's always there. It's on the default tab. The assembly transparency, what happens when you go into edit component? Default is force transparency, where everything except for the part you're working on turns transparent. Opaque, everything stays shaded. This other one, maintain transparency, everything stays shaded unless it was transparent before. Like if you've got a piece of glass or a piece of plastic that's transparent, that'll stay transparent when you have maintain transparency on. Where if you have opaque, it actually forces those into shaded. So 3 different flavors you can get, but it only comes up whenever you're in that assembly. Right when you hit edit component, it's going to be on that toolbar. So, and once you set that, you close out of SolidWorks, it'll write to your registry, and that'll be the way that it rolls from then on. All right, so just fitting this together. Also, when you are dealing with this top level approach that I'm doing, it's all using the same origin because they're all using that same, that base sketch that I used at the beginning to find their location. So if you just hit the green check mark, it's always going to mate right into place. When you are talking about load times and rebuild times and things like that, especially, I'm sorry, the rebuild time is the main one. When you open up an assembly, first it takes forever to load up those files. You can get through that with, not loading up the stuff in the background, like I showed you flipping that switch where external references don't get loaded up. Also, you can do lightweight where it doesn't actually load all the parametric information. It just loads the graphic geometry. So that's the way to get across that first big hurdle that you have when you open up an assembly that you're waiting for it to load. And you'll see the little slider bar down in the lower left as it's loading up the parts. Then you might have a time where after it's even got all the parts, it's still taking a while for it to get to the point where you can start clicking and working in SolidWorks. The other thing that it has to do is it has to solve all the mates. The mates have a little bit of a different time thing. Stuff that's like coincident or concentric, those type of mates are really easy to solve because it's just bam right there. But if you have like an angle mate, a distance mate, a limit mate, things like that, then it's got to compare it to another piece of geometry and put in a dimension. And so if you have a lot of those types of mates at your top level, it takes longer to resolve. Gear mates do that as well. Any type of mate that's not just, hey, put it here. But what takes no time is a fixed component. So when I open this thing up, all I got to wait for is the parts to load up. It doesn't have to solve any mates because I actually don't have any mates in this assembly. Yes, sir.
So say if you wanted to avoid all that loading everything up, you wanted to show this to somebody, is there a design review?
Yes.
That way you can just show them this, and not have to worry about loading everything?
Absolutely. So let me save this, all the changes that I've got here. So there's three ways that you can operate when you are loading up the parts. Resolved is the longest. Resolved's going to load every single component into RAM. Lightweight is next. Lightweight only loads the graphic information, sort of like, what an E-drawing is? It kind of just loads that E-drawing into the space. It shows you the part in the feature manager tree. I can show it to you right now. So if I load this thing up lightweight, took no time. You didn't see a big slider where it was loading up 5 or 6 parts. It just loaded up the assembly. But if you notice, there's only reference geometry. There's no actual physical features in here because it didn't load up any sketches, any geometry, any dimensions you put in. If you want to work on one, you can either right-click on it and set to resolved. That'll load it into memory, and now you'll see I have the features to work on. Or if you double-click on it in the graphics area, it'll just load up that part, because typically you're not going to be working on 24, 25 parts. You're only going to be working on 2 or 3. You can load it up lightweight and say, okay, double-click that one, double-click that one, double-click that one. Now those 3 are in RAM, and I can work on their parametrics. And I don't have all that. Not only does it load up faster, but it also doesn't take up as much physical memory inside your machine. So your machine's going to run faster because it doesn't have all that, it's like trying to run with a full bucket. The last one, what you were talking about, is this one called Large Design Review. That takes even less time because there's nothing. There's not even reference geometry. The lightweight is nice because you can take the reference geometry and you can still mate the thing into place using its planes or using its physical geometry. Here, I can't really work on anything. All I'm doing is I want, hey, how far did you get on this? It looks like that. But I didn't have to wait if this thing was fully parted out. I wouldn't have to wait 10 or 15 minutes for the whole thing to load before they're like, well, can you revolve it for me? You can go in and open a particular subassembly and work on this. When you make a change here, it'll ask you, do you want me to update the graphic geometry? If you say no, that large design review has no changes at all until you resolve it. If you say yes, it'll resolve what's changed. So it might take a little time to update the graphics on that, but that's all it's doing. It's just swapping out the old graphics for the new graphics. And if you're interested more, we got, I did a assembly design class that covers it in more detail, which is available on our XSC training website. And I usually send that out when I send the video out for this. I'll send you the link because we've got, I think, 7 classes out there that are just like this, 2-hour seminars that go in depth on, advanced topics. Okay, some other ways of doing top-down design. I'm sorry, master modeling. So I've shown you split part, save part, pretty much the same thing, only split part has that one other step where you can start breaking things up into multiple parts. But at the end, they can ship out the bodies as their own derived parts, put them back together as an assembly automatically. I also showed you the insert part where you can bring all of the information that you want from a part into a derived part. Another way of doing this is to actually just take the body that you want and create a part from it. It's sort of like the insert part. It's kind of sort of like a hybrid because, again, just like the split part and the save body, I only get bodies that I can ship out from here. I can't ship out reference geometry or sketches. So if I were to right click on this, I have this choice to insert into a new part. I can even give it a name on the fly. And what it does is it just shoots out that body as its own part. There is no time dependence. That's one of the reasons I like doing this is when you're doing that split part, I hate the fact that I have to, anytime I put a hole in it, I got to drag that hole above the split part. Here, it's just looking for the name of the body. So if I go back into here and I realize that I needed to drill a hole in the bottom of this thing, I drill a hole in it. When I go back in here, it's got a hole in it. I don't have to worry about, oh, I did that before the split or after the split. As long as it's got the same body name, it says, oh, this body now has a hole in it. So
It says that at the end of after everything's
it doesn't matter where you put it in the tree because there's no time dependency. When you do this ship out, you're just shipping out that name. So all this thing is looking for is the name of that body.
roll back for that.
Hole goes away.
It's sort of time dependent, it's always at the end.
Well, yeah, it's got to be a fully rebuilt part.
And it's at the rollback bar.
Mm-hmm. So yeah, anytime you've got it rolled up before things happen, but that's going to happen regardless. But that's why I like to do it this way rather than doing the split or the save bodies. It's just because I don't have to worry about when I go and make a change. I just want to make the change and go back in and see that change happen. I don't have to think, oh, that change has got to happen here in the feature manager tree. So it makes it a little simpler. So this is my personal favorite besides the insert part, definitely, but it's insert into new part. And you can actually do more than one body at a time with this if you want to. So if I go back to original, let's say I want this rudder and this to, not that one, this. Maybe I want that to be a multi-body part still for whatever reason. If I right click and say insert into new part, it's going to take both those bodies and put it into the new part for me.
You say what about the other multiple parts?
Yeah. If you really wanted to, there's no reason why you couldn't. trying to think of like if you were going to do different assembly configurations and maybe you wanted one that had a hole in it, one that didn't. Once you ship this out, I could drill a hole in it, save that as one part number, do it again, save it as a different part number without the hole. And they're both referencing the same master model, but they have different things happen to them after they've been shipped out. So yes, his question was, can you save out to multiple parts? And definitely you can. For the example that I talked about, if you want to use the same base geometry, but you have different ideas for what happens to that base geometry afterwards, you can definitely do that. And these still have the same origin that they had from the master model. So I get that same benefit where if I create an assembly, as long as I just hit the green check mark, it shows up with the same XYZ as the master model. Oops, I just want that one. And of course, because they're all using that same one, if I do put in this assembly, it's just going to snap right into place. Okay, a couple other ways. I was wondering if I was going to have 2 hours worth of time. I'm definitely going to have over, so I'll make these last two short. Of a couple other ways that you can take master model geometry and create derived components from it. Now I've used envelopes before in the past. So what an envelope is it's like a placeholder. I can turn it on here at this level. Or if I forgot to do it, you can always right click on the component, go into the properties, and there's a choice that you can toggle on or off the envelope option. First thing you'll notice, it goes transparent, so you can see through it. Also, if you look in the feature manager tree, it's got a little snail mail envelope icon showing me that it is an envelope. What is an envelope? An envelope will not show up in your bill of materials. It will not show up in your mass properties. It's a phantom. It's just that shape in your assembly so that you can reference it. Maybe you want to mate stuff to it, or in this case, maybe you want to insert new parts. You have to save out the Now, what I can do with using this type of command is I can grab information from this envelope and use it as an external reference. So rather than me taking the part and breaking it up into pieces that all reference this, I can take that part, drop it in an assembly, and inside that assembly have them all reference that one component. Again, the idea on the master model is you always want the references coming from that one component, but you don't necessarily have to break it up into separate bodies if you don't want to. You can also ooh, I picked the wrong plane. Okay. Get out of this sketch. Actually, try that again. So I'm gonna, problem was that I was trying to grab information off the wing, but my plane didn't actually cross the wing. So let me start a sketch on that. And I can again, here's where my external reference is going to come in. When I copy, not convert, but actually intersection. So what the difference is when I pick those two faces, if I convert, it's actually going to project that shape onto the sketch plane. When you do an intersection, it's just where the sketch plane crosses that geometry. So rather than getting all the edges like I did before, it's just showing me where these actually cross. I'll pull these back. Come here. And create a little spar inside this wing. But now this has that external reference to the original. So this is sort of like a top-down, but you're using the master model. Or if I go into it in an envelope, it's got all the geometry that you want. So if I were to change this geometry, it's got the rebuild symbol here. When I rebuild this thing, then gets thicker, that spar still fits inside of the wing because I'm using the geometry from the wing to determine where that sketch is. Another way of doing that same sort of thing is if I were to open, let's say, this wing on its own. Another way that I could have done that is I could have exported the exterior of this wing out on its own. In that last one, when I was doing the option where I did insert into new part, I was using a solid body. You can use surface bodies too. You can actually use a combination. You can say, I want these surfaces and these solid bodies to all be pushed out. So if I pick this face and do a quick offset of 0 to copy it out, I can right click on this body, insert this into a new part, and I just get that surface. Now I can start developing this part, just referencing that body. And this one, I think it's a little bit more robust. The other option, and I'm just, like I said, I just want to show you all your options and you can make a judgment on whether you want to use them or not, is that other one was using the top down, which people can get into trouble because they can start not only referencing the master model, but then referencing the other models that reference the master model and become a headache for themselves. But also, if I just ship out a surface, I can use surface tools like cut with surface to make that spar fit perfectly inside there. The other one, you notice that I pulled back the edges a little because if I'd actually done a round on either side, the spar would have stuck out the front and back of the wing as it started to get narrower. Where here, it's going to fit in perfectly into that shape. Okay, do you have any questions on anything I covered today? Hopefully this was helpful for you in design. Master modeling technique is good if you know the pitfalls and know how to get around them, or you know the basic idea of what we're doing here. Why are we doing it? We're using that external reference, but it's not as helter-skelter as doing just top-down where you don't know where the references are coming. The references are all coming from one single location, and you make all your changes at that one location, and your assembly should update with changes. All right, this has been recorded. I will ship out everybody that signed up for this, as well as everybody on the SOLIDWORKS mailing list. The recording, it's going to come out in a couple days. They upload it from the AV group, and then I have to like convert it and put it on YouTube. Anyways, I'll also send out an invite for next month. Next month, we're going to be doing shortcuts, tips, ways to game the system, make SOLIDWORKS work faster for you. And that's it. Thanks everybody for coming. Are there any more questions, Ed? Sorry. No, we're good. All right. Thank you.